Welcome back to Rubixx Structures. In today's tutorials, I'll be showing you how to design concrete piles using ProtaStructure. Whether you're working on a deep foundation for a high-rise building or bridge, understanding how to design piles is crucial for stability and load transfer. So by the end of this video, you will know exactly how to model, how you're going to analyze reinforced concrete piles efficiently. Alright, so please just hang in there while I take you through this process. Okay, so the first thing you're going to do is you go to your Prota details. I'm actually using Prota details of ProtaStructure 2022. So whatever Prota detail, whatever version you're using, this still applies to it. Okay, so you come to your design library, you click on your design library. Here under your design library, you realize that you can design a whole lot. Under your design library, you can design a cantilever retaining wall. I've made a video on how you can design a cantilever retaining wall. You can check out my channel too, so you can know how to design your cantilever retaining wall. Also stairs, you can do retrofitting wall, but what we are going to be doing today is just pile designs. So you just scroll down and you come to where you have pile design and you click on your pile design and give it a few moments. Once you click on it, you give it a few moments while it brings out the menu. All right, so from here, this is what you have. So the first thing you have is your pile geometry. So our pile label, we're going to leave it as P1. Section type is going to be a circular pile. Pile type is going to be board. If you click here, you can see a pre-stressed front, but you are going to be using a board type. Stirrup type, you're going to be using a circular stirrup, or you can decide to use a spiral, but you're going to be using a circular stirrup. Okay, so our pile length for this particular pile is going to be, we're going to be using a 6-meter pile for this design. So for the penetration we're going to be using a penetration going to be 200. Okay, right, so the reference level is where your pile starts. Okay, so our reference level for this pile we are going to be designing is 0. Okay, it's going to be starting from 0, the ground level. All right, so okay, you can see what happens here. This is the ground level of 0. Right, so this penetration is how long. Your penetration means how much of your pile is entering into your pile cap. Right, that's what the penetration means. Okay, so you're going to be having a penetration of just 200. All right, so the concrete cover by the sides, usually advisable when you're talking about foundation because of groundwater and all of that. You know, you need to make your concrete cover thick, so you're going to be going with 50 for our side cover, and our section diameter are going to be using a 600 diameter pile. Okay, so after that, next you're going to do is for you to come to your design. When you come to your design, you come to your working load, you click on working load. All right, so most people have this wrong. All right, so this is what we're going to do. So I'm going to show you. I'm going to be opening my calculator. Sorry, I'll be having my calculator. Click that so I can. Right, so for your axial load, when you have a working load and you have an axial load, a force, let's assume we have at that particular point where you have your pile, there is an axial load coming from your columns. You have an axial load of, let's just say we have an axial load of 900. Okay, let's assume you have of 900, and let's say your pile capacity for a 600 diameter pile that is from your saw report, the safe working load of that your pile, it's, let's say, is about 360. So you have 900 divided by 360. That means at that point you need like 3 piles at that point. Okay, so you're going to be providing 3 piles at that point. So this axial load, this working load, means if you're providing 3 piles to support 900 kilonewtons, all right, what is the working load of one single pile? What that means now is that we're providing 3, so you can just clear this. We are providing 3, so it's going to be 900 kilonewtons divided by 3. Okay, so that's 300. That means our working load, our axial load, is going to be 300 kilonewtons. 300 kilonewtons. Hope you got how we got that. All right, so that's how you get the axial force for this, the working load of that pile. Okay, so after the next we are going to come and check is we are going to come and you're going to come to our materials. right? Our concrete we are going to be using for this design, we are going to be using a C2025 grade of concrete, okay? And our rebar material, we're going to be, our rebar is going to be 410 type 2, okay? But then if maybe you did your steel, your yield stress test for your rebar, you could add a material here too, but we're going to be using the design into 410 grade 410, okay? And also a link material where it's going to be the same as 410, okay? So we can click OK, right? So rebar diameter, you realize that, as I've said earlier in my previous videos, these new versions of software, this is what happens. So if you hover your mouse around it, you realize that here is columns, here is for the wall, here is for your beam, here is for your slab, and the rest of it. So for our columns, Prota designs, your pile is a compression member, so it designs it as a column, right? So what reinforcement we want it to provide, the list should be Y16 or Y20, all right? Okay, so we're not designing a wall, we are not designing a beam, so you might not need to change this. We are not designing a slab, we're not designing a rib slab. Okay, for footings, we are not designing any footing, but then we can just keep it at 6, but we're not designing any footing. Is the links, okay? So what links are we going to be? We are going to be using Y10 as our links, okay? So you can just click your Y10 alone, okay? So you've selected reinforcement you want it to provide for your part design, so you can just click OK. Okay, once you've done that, you come to your soil profile. Okay, you're done with design. We're done with design. If you click on lateral load, you understand that it's going to open this anywhere you can impute, but then we are not designing with lateral analysis, so you can just off that. Okay, come back to soil type. Here we can get this from our soil report. Okay, let's go to a particular soil report that I have here. Okay, so this is a soil report I have here. Okay, let me just go to where we have something that looks like that. Okay, so this is it. This is the log. What it means that at depth of 0 to 0.25 meters, you have thickness, we have a dark brown topsoil. Okay, so what this means is we could change it. This is where you can use that to change it. Okay, so at an interval of this, so we can change and work with that, but because of time of this video, we'll not be changing this, but then you could change this with respect to your soil report. All right, like I've said earlier, this is it, the depth and the type of soil. Okay, the depth and the type of soil, so we can use that to check and know this is a dark brown topsoil. From the soil report here, we are using is from 0.25 to 3 meters depth. You have a reddish brown sandy clay with gravel, all right, and all of that. So we could change that relation to this, but because of time we're not going to be changing that. Okay, come to our design parameters. So group efficiency, spacing in diameters. According to Eurocode allows you 2.5D to 3D, okay, for the spacing on your pile, so you can just leave this as 3D. Number of columns is going to be one column at this point. One column at this point. So number of rows is going to be one row at this point. All right, so automatically it has changed your efficiency factor. Efficiency method, we are going to be using the converse Labari. Okay, you can check this, but then we are just going to be using this, leaving it as default. All right, so factor of safety for end bearing capacity is going to be 3.0, and a factor of safety for shaft resistance is going to be this. All right, okay, so you just leave that. So you come to our SPTN values, and also this can be gotten from your soil report. Okay, so we check our soil report as we did earlier. You scroll down, you're going to see this is the SPT results. All right, so we have at depth of 0.3 meter minus 0.3 meter, SPT is 6. So if we had changed this, so if we had changed the depth from this soil profile, if we had changed the depth here to about, let's just say we change this to about 3, sorry, okay, if we had changed that to about 3,000, so now XPT here for 3,000 Okay, you have SPT. If you are going to be using this, the first ball, SPT value here is going to be 6. Right, so we can just put an SPT value here of 6. Okay, and you do that subsequently for others. SPT value of, when you reach the depth of 0.6 meters is 6. When you reach the depth of 0.9 meters is 5. Depth of 1.2 meters is 4, and there you have it. You reach the depth. All right, that is it. But because of time, I have said earlier, we're not going to be changing most of this, so we can just leave this back as 8. Go back to our saw profile and change this to 1500. Okay, we're not going to be changing any of that because of time. But when you're doing your design, please make sure you follow this based on your soil report. Very, very important. When you're doing foundation design, you need your soil report. It's very, very important. Okay, SPT and values. Okay, so when you do that, next you're going to go and calculate your working load. So you click on it, calculate working load. So it has calculated your working load. So the working load is using for this design is 399 kilonewtons. 399 kilonewtons. All right, so you can click on this to see your diagram. All right, depth to working load. All right, this also, if you had plotted your values for your SPT and your soil profile properly, this is already plotted in your soil report. Right, so if we come to our soil report, and let me just show you where that graph is. Okay, so if you come to our soil report, this is it. This is the graph, depth to your working load. All right, depth to your working load. So if you had done your SPTN properly and your soil profile properly, you should get that diagram properly. Okay, so this is it. So you can come back to your power design, your design, to see what it provided for you. Right, so from there you can come to your report and details. So you can tell it that you want to add a quantity table to your drawing. All right, so link concrete thickness is 100. That's like your blindness 100. So all right, so you can just click it for it to create your report from what it has designed. Give it time. Once you click on report, give it time for it to load your report. Right, so this is the power report. So you can just scroll down to see what we did. So you can see the rebar. It provided 11y16. Okay, once you see this, what this means is that from the load coming on this 600 diameter pile, right, you realize that it has provided slash required. It has provided 2211.68 millimeter square of reinforcement, as compared to it requiring 0. When it says that it requires 0, it means that the concrete alone in this pile can carry your building. Okay, but it's always advisable, according to the code, that you provide reinforcement, longitudinal reinforcement. For a 600 diameter pile, minimum should be about 6. Okay, but then it's providing 11, but then it requires 0, meaning that the compression capacity of this concrete alone can carry that. Okay, same with the links, but then it's providing y16. It's providing y16, which is quite funny, at 200. Right, but we can just go back to tweak that. You can come back to here, come back to your design. Okay, we could change this to about 10. Okay, so 10 still works. Let's see if we can change it to 6. Okay, 6 doesn't, it's saying it's X, right? But then we can just keep it at 10. But you know fully well that the compression, so you can use 6. And links we are going to be using, okay, we didn't, okay, maybe it's because of so you can come back to your rebars, link rebars. Okay, just select Y12. Okay, so you just click OK. Okay, So that's it. It's meant to be able to select, you are meant to be able to select Y12 for sorry, Y10 for our links. I don't know why it's not selecting Y10 for links, but we should be able to do that. Okay, so yes, we have clicked that, so it has provided Y10 for links now. Okay, Y10 for links, and providing Y16, 10 Y16 for our longitudinal bars. Alright, so we can check back at our reports. Click our report, check where I developed the report, so you will see that's changed, providing Y10 now links, and also longitudinal reinforcements Y16, 10 Y16. Okay, so you just scroll down. So this is the report. You could change this to PDF. Just click it here and it changes to PDF. All right, so we could have a detailed drawing by clicking OK. Once you click OK, click any point on your drawing space. Okay, and you zoom in, and it has done your pile detailing for you. Alright, so this is a section of it. These are your longitudinal reinforcements. This is your link. So the part diameter is 600 millimeter, and this is your quantity table. Okay, so that is it for the design of pile using ProtaStructure and ProtaDetails. If you found this video educative, please don't forget to subscribe to the channel. Don't also forget to drop a comment on whatever